Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating. Now we continue on with part 4 of chapter 2, design. The section we want to go over is something called a section called 403. The chapter begins with some general notes about the design, and they're worthwhile going through for sure. And this is where we talk about the wall thickness calculation, how we determine how thick of a pipe is required. This is basically the basis of it. The flexibility analysis was done earlier, and it's another set of issues. Now we head off to section 403.1, general notes. Design and installation. The B31.4 starts by stating that engineering methods, material strength, and applicable design conditions must be considered in the design. So they provided some basic ground rules, but they're saying that engineering methods must prevail. Next thing is protective measures. So protective measures to pipelines from unusual external conditions must be considered in the design. These include items like river crossings, offshore and inland coastal water areas, bridges in areas of heavy traffic, long self-supported spans, unstable ground, vibration, weight of special attachments, forces resulting from abnormal thermal conditions. Let's continue. There's a section I call code values. So the B31.4 does not want any deviations of the allowable stresses, like the yields and values. They want you to use the value shown in the code. They don't want you to use the upper value. They want you to stay with something that's standard. Secondly, during construction and operation, external pressure can exceed the internal pressure because when a line is pressurized, for example, it can handle a lot of external loads because the internal pressure offsets the external pressure. So during construction and operation, this must be considered. Okay. Nozzle loads. These are forces and moments transmitted to connected equipment. That has to be considered as well. So that can be from valves or piping interacting onto valves, which I remember a few years ago I've experienced that problem. Strainers, the same idea. Tanks and pressure vessels, and pumps. Now here are the last 2 points to go over. It's about coatings, external or internal coatings in cement. They say that you should not use them to add strength to your part unless you can prove so. I've experienced this problem considerably over the years with liners for wear and so on. And basically what I discovered was it adds more to the stiffness of the component and it reduces the flexibility of the component. And in my opinion, that should be considered. If you need some help to understand that, please feel free to contact me. I'd be pleased to help you. Now onward to the last point, pipeline inspection. All the components, the inside diameter must be large enough to allow the line to be peggable. That's why you see a lot of specs for valves and stuff that they're all pipeline valves, and they're all part of the reason why there is all these different specs is for this piggable, like making sure your inside diameter and your clearances are acceptable. 403.2 is the section where a designer determines the required thickness for a pipe. Recall that nominal wall thickness is typically based on schedules like schedule, standard schedule, extra schedule, and they're based on standard sizes. And there's also other standards where there's specific thicknesses provided. So as long as you're greater than your required your calculated thickness plus all the different allowances, you're fine. So this is the equation. So that's the nominal thickness of the pipe plus the calculated thickness plus all the allowables. So this is the calculated pressure thickness, the sum of the allowable. So that would include tolerances, corrosion, erosion, and wear, threading, and grooving. And we'll get into that in the next few slides as well. So the first part we'll talk about is the T, the calculated thickness. Back in the previous slides, we had shown you basically a stress model of the forces that are in a pressurized pipe. So we had the longitudinal stresses and the hoop stresses. Okay, so in this case, we're using the hoop stress to determine the wall thickness of the pipe. Nitty-gritties of determining the wall thickness of a straight pipe. Recall from earlier presentations that these two equations, one on the left is imperial and the other one on the right is for SI, is the fundamental hoop stress equation. And it was introduced earlier, but now it's been rearranged because you're solving it in terms of the thickness T. So D, as you recall, is the outside diameter of the pipe, and that is basically a manufacturer value. And PI is the internal gauge pressure that you're seeking for. And the next value is the applicable allowable stress values. Now this is a new term that we are introducing. But to also recall, when you do the wall thickness calculations at the end of the day, you have to make sure that your D over T is less than 20. So you have to do some iteration. So just a little bit of a warning there. Now S is the applicable allowable stress, where F is the design factor, and I go to table 403.3.1, and this is where you can get the proper F value for your equation. And then you've got your weld joint factor. The weld joint factor is basically determined by whether your pipe is seamless or it's a welded spiral pipe, and then a level of inspection associated with that. And the SY is the minimum specified yield stress, and you get those from the applicable material specs like API 5L, and you can borrow those values. Now let's look at the applicable allowable stress values. Once again, if you go to table 4.321.1, you're going to see the weld joint factors. For example, ASME A106 pipe is seamless pipe, so the joint factor is 1.00. So it has no effect if it's seamless pipe. The other one is the one. My preference is to, this is sort of a summary, and basically we're focusing right now on the internal external pressure equation. So for restrained and unrestrained pipe, and for riser and platform piping and navigatable waters, we use essentially a similar equation, 0.72 for restrained and unrestrained, and then for the riser one we use 0.6. So that's that F factor we talked about earlier, and that's basically it. Now we're going to go talk about the A factor, the allowances, some of the allowances, and more detail here. So we said earlier this is tolerances, so the thickness and defects in a pipe refer to the applicable codes. The standard for like an ASME type piping is 12.5% plus or minus, and so you have to consider that in your Hoops stress equation. Corrosion erosion allowance. There's a section on called Chapter 8, corrosion control, because that can have an effect on reducing your corrosion allowance and the amount of entrained air in your system, and that's another factor to take into account. The other one is threading and grooving, and I would you to check section 4.04 8.3. So you basically add those all up, and then plus the thickness, and then as long as you're less than your nominal thickness, which is your standard pipe size, then you're ready to go. Section 403.2.5, there's some notes on high D over T ratios. Now, we mentioned that before, but there's some other things that you need to consider during construction. Your D over T ratio, and I've modified that to show T over that's the nominal thickness, okay, and it's something in the code that they should be saying nominal, not like the thickness. Must be greater than 100, and you have to provide protective measures during construction. And so also, I guess that would include, say, for example, the existing condition of it as well. But anyways, there is another section here for offshore liquid pipeline systems, and they have a table in their respective section, A 402.3.2.1, where they have special rules on the high D over T ratio. Okay, so that concludes my presentation. I hope you enjoyed this presentation. If you need any more help with these wall thickness calculations or spreadsheet or anything, just feel free to call me. I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.